This is the 5.4 mini lesson. Jamie was complaining to her brother about having to do homework problems with fractions like this, so multiple. Jamie said, I have to find the least common denominator, convert the fractions to equivalent fractions with the least common denominator, then find my answer. Her brother says, why don't you just use decimals? So let's use Jamie's method. If I look for a common denominator with these, I'm going to need to go to 20. So 2.5 going to 20, this would be times 10 times 10. If I go to 20 here, it's times 5 is 15. And if I go to 20 here, it's times 4 is 8. So I'm going to put two of these together first. I'm going to do these because they're both positive. So these two together would give me 7 and 18/20. Now I have plus negative 3 and 15/20. So I have to remember my rules. When I have signs that are different, I'm finding their difference. And the absolute value of this is greater than this, so my answer is positive. So I just need to find their difference. 7 and 18/20 minus 3 and 15/20. 18 minus 15, 7 minus 3, 4 and 3/20 is my answer. If I want to do this converting each one of them to a mixed number, to a decimal, I'm going to take 2.5, which I know is 2.5, plus negative 3.75, plus 5. I know 2/5 is the same thing as 4/10, and 4/10 is 0.4. So again, I'm going to put these two together, and I get 7.9 plus negative 3.75. I know my answer is the sign of the larger absolute value, positive. Signs are different, so I need to subtract. 7.9 minus 3.75, I have to line up decimals. Just regroup here. I get 4.15, which is the same thing as this. So at this point, it really wouldn't matter which way you solve. So it's up to you what you think would be easier here. But Jamie says, well, that's okay for that problem, but what about problems like the next one? So we're going to take a look at this problem on the next page. It says calculate using Jamie's method. So when I look at 3, 6, and 2, my common denominator is 6th. So I have 5 and 2/6 plus negative 4 and 1/6 plus negative 2 and 3/6. So if I use Jamie's method, I think I'm going to put these two together first. A negative plus a negative stays negative. So I know my answer to this part is going to be negative. And when the signs are the same, I find the sum. So I'm adding these two. So I see I get 6 and 4, 6. And I know it needs to be negative. So now I have 5 and 2/6 plus negative 6 and 4/6. These signs are different, so I have to find their difference. Absolute value of this is greater, so I know this answer is going to be negative. I have to find their difference. So the larger absolute value is on top. When I subtract, I get 1 and 2/6, which is 1 and 1/3. Put it back here because it's negative 1 and 1/3. This is my solution. Will her brother's method work for the second problem? Well, if I look at converting the fractions here to decimals, when I take 1 divided by 3, I get a repeating decimal. That turns into 3, 3, 3, 3, 3. So because I'm going to get a repeating decimal, I'm not going to get an exact answer. So this would not be the best method to use. So the brother's method will not be as precise of an answer because we get repeating decimals. So I'm going to jump over to here where they give us a lot of vocab. Decimals can be classified 4 ways. We can have terminating. So I'm jumping down here. Terminating decimal has a finite number of digits. That means a specific amount, meaning that the decimals will end or they terminate. So for example, 1/2 equals 0.5. They can be non-terminating. Non-terminating decimals are decimals that continue. They don't end. When you have non-terminating, you could have 2 different kinds. That's why I called this A. These 2 are really under this. You could have non-terminating that repeat. So like our 1/3 example, just keeps going, 0.33333. Or I can have non-repeating decimals. They still don't end, they don't terminate, but they don't repeat. And if you think about that big number pi that I have on my wall, that's an example. Then we need to know bar notation is used for repeating decimals. And it's just that bar that we put to show that it goes on forever. So in 1/7 we see that 142857, 142857 keeps repeating. So we put a bar over the entire part that repeats. If I had 0.333 and it just keeps going, I could just write that as 0.3 with a bar above it. Let's say I had a decimal like 4646 and that keeps repeating. I could just write 46, a bar above both the 4 and 6 because that's the part that repeats. If I had a decimal like 0.5777 and that keeps going, I would write that as 0.57 and a bar only above the 7, only above the piece that repeats.